Hey everyone, good morning, good afternoon, good evening, depending on where you are. I'm Anthony Fiore. I'm a partner solutions architect here at AWS, and for the next hour, I'm going to be talking to you about some of the security components of the Certified SysOps Administrator Associate exam. So I'm going to try as best I can to pause for questions. So if you can, if you have any questions, have anything, I don't bite. Feel free to just throw them out in the chat, and I'll be happy to get to them. So a little bit about me. So I've been working for AWS for 3 years now. I've been working with AWS as a customer for longer than that. And most of my 20 plus years is actually in the IT industry, but not working with cloud, but working with some of the larger scale Unix systems, storage and backup systems as a customer. And I was fortunate enough to be able to pivot to working with AWS at my former employer. And as I started getting to work with them on it, I started to acquire certifications. And since late 2016, I've been fortunate enough to get 7 certifications. I've got all the associates, I've got the 2 professionals, I've got the cloud practitioner, and the security specialty cert. So I'm not saying this to impress you. I'm just letting you know that I kind of started where you were. I knew how to spell AWS, and I started from nothing really. So, and I kind of grown, and I'm just telling you this because I want to let you know that it is possible to kind of come from a completely different background into cloud computing and build a successful career in cloud computing as well. So it is possible. Nobody's just born knowing, all the different things, all the different components of AWS. And I could tell you, having been on the other side for 3 years now, there's still a lot of things changing on our side, and it's tough enough for us to keep up on the AWS side with all the different services. So it's a constant challenge. So kind of just wanted to get started with that. So the way I'm going to do this is I want to just take a bit about the exam. If you're attending this, you're probably either looking into the exam, the SysOps exam, or you're currently studying for it, or something you're aspiring towards. So there's a couple of key things I want to make sure that we're aware of here, and then I get to into some slides. But I think the biggest thing to understand about the SysOps exam is that the format for SysOps is changing, and it's going to be changing very soon. And if we look here in the announcements, I think this was announced probably earlier this year, where there's going to be a whole new format, and that they're starting with the SysOps exam. I don't have any information to know if this is going to be going with other exams like the Solutions Architect Associate or developer associate, specialties, or any of the pros. But I think it's safe to assume, just knowing AWS, if they start with one thing, it's eventually gonna get to others. So, and what I'm talking about specifically is the fact that there's gonna be a lab component, a hands-on lab component to the exam. It's no longer gonna be just multiple choice. And that's big, right? Because what was most successful for me in preparing for the exams, especially when I was new to it, is just having a hands-on component and being able to work with it, because it's very different for me to work with something, because then it's and answer a question than just kind of prepare for the test and go in and think I knew all the questions and everything like that, right? So that really changes the game here, in my opinion, a lot, because now they're not just going to be looking for additional items, but now they're actually going to look at you. They're going to present you with a problem or some sort of a scenario, and they're going to give you an opportunity to go and actually do it in the console. So the exam now is in beta, but as of 6/29, which is about 2 weeks from now, is going to be the first day. If you haven't registered for the SysOps Associate yet, if you wait 2 weeks to do it, you're going to be registering for the new format. And the last day to take the old format is going to be the end of July. And then if you register for it in 2 weeks, the first day for the new format, what they're calling the CO2 format, is going to be the 27th of July. So really important for those who are studying. You know, it's a good opportunity for you to, if it's something you're not comfortable with the lab portion just yet, or you kind of don't want to do that just yet, now's the time to register because the last day to be able to take the old format exam is going to be July 26th. So get to that fairly soon. So I'm going to be kind of focusing on the way I kind of structured this is kind of a blend between old and new. There's a lot of topics here. I mean, security is a very deep topic in AWS. It's what we consider it job zero, and it's not something I can cover in an hour. It's probably something I probably cover more in a half day. So I'm going to just kind of give you some items to kind of focus on, and a lot of what I kind of covered here is coming straight from the exam guide, right? So this is the newer format exam guide. If you go to our site, aws.amazon.com/certification, you'll be able to download these exam guides, also sample questions, but this really gives you an idea of what you're going to be tested on. So you can make sure that you know things like CloudWatch and things like autoscaling. SysOps is there is an operational component to it. So the operational excellence portion of the well-architected pillar is very big here in terms of provisioning, monitoring, security compliance. There's also some networking and some cost optimization, but this can get pretty deep. And so I know when I took this many moons ago, to me, this was about the toughest. This was the toughest of the three exams that I took at the time, between solutions architects, the developer, and the SysOps. But that was a long time ago, and I'm sure they're still just as tough now. There's also the sample questions here, right? So we're going to talk a little bit about organizations today, right? So if AWS organizations is kind of it's a different way to manage multiple AWS accounts, and we'll talk about why some companies decide to use multiple AWS accounts and strategies and whatnot. But we see here in the sample questions that there's 2 questions on AWS organizations. So definitely something you're going to want to take a look at. And then the newer format for the sample questions also has what a sample exam is going to look like, what the sample lab is going to look like, right? Being able to go in, create a custom parameter group, and provide, and then take some snapshots, right? Fairly simplistic, right? But again, this goes back to I've been working in the AWS console for years now, right? So to me, it's something I can do very easily. If you're not very familiar with AWS console, where to click, time is your biggest enemy with any exam. So although you probably could find it, it's probably going to if you don't know exactly where to go for it, that's going to just eat away at the clock for you. So I'm going to kind of with that said, I'm going to pivot now into the slides. And like I said, if there's any questions, just go ahead, throw them in the chat. Tim, would you mind just confirming for me if you can see my slide deck here? Shared responsibility model. Or can someone throw in the chat if they can see my screen? Just so I'm not talking to myself or talking about slides that don't exist. All right, well, I'm going to go ahead and continue anyway. If for some reason you can't see it, just go ahead and let me know. So first thing to talk about, and which may come up on the tests, is talking about our shared responsibility model, right? And the shared responsibility model is pretty key in my opinion. So just kind of understanding what's an AWS responsibility versus what's a customer responsibility, right? We see things in the news where customers have unsecured S3 buckets and whatnot. And you know, when I was on the customer side, I looked at that and said, hey, it's not secure to put things on the cloud. And then once I learned more about S3, it was like, no, it's not secure because this was a customer responsibility to properly secure their S3 buckets. So it's not it wasn't on AWS to secure it. It wasn't an AWS responsibility to properly secure these S3 buckets. This is a customer responsibility. And whether it be a customer responsibility, oftentimes it's a contractor who's going in, creating S3 buckets, putting in data, and just being lazy and not following the proper security protocols, right? And because they're contractors, they don't, it's not their patch. They don't really own it, but whose name gets thrown in the headlines? It's the customer of that contractor that says XYZ company had all their customer data just exposed because there was an unsecured S3 bucket. So these are key things to kind of understand in terms of what's an AWS responsibility and what's a customer responsibility. So in general, easiest way to think about it, rather than going line by line here, is that we're basically we being AWS, we're responsible for the security of the cloud. So what does that mean, the security of the cloud? So things like the infrastructure that things run on, right? So we're responsible for the data centers, the availability zones that run within that run those data centers, the regions, the edge locations. We don't publicize where these data centers are. We don't give the specific addresses there, right? And for anyone who needs to actually gain access to a data center in an availability zone or one of our edge locations for CloudFront, for example, there's a pretty rigorous process. I can tell you, having been an AWS employee for 3 years, it's not like they give us tours of data centers. I don't even know where they are. And if I did know where they were and I just showed up and said, hey, can I get a tour? I'd pretty much be told to go back to wherever I came from in a not so nice way. You basically have to have a reason to go to one of these data centers. So physical security of the data center, but also maintaining the power, maintaining the cooling, and things like that. That's all an AWS responsibility, right? So customers don't have to worry about where their power and cooling is coming from. That's all us. So we're also going to be doing the racking and stacking of things like compute, storage. If it's an RDS service, right, we're going to be responsible for more than just say what we would be responsible for, say, an EC2 instance. As we start going further up the stack, and we start looking, from your standard, say, EC2 services, that we'd be responsible for the underlying host and the underlying hardware that runs an EC2 instance. As you go further up the stack to say things like RDS, now we are responsible for the underlying operating system and everything, because we're not providing you access to the underlying operating system because that's something that's within our control. So those are some of the key things you're going to want to understand in terms of, especially with some of these higher level services like RDS, like SageMaker, right, where we don't expose any of that underlying infrastructure to customers. And that's where you're going to kind of want to understand the differences between something like that and, say, running a database on EC2, right, and where that shared responsibility model is. Beyond that, on the other side, customers are responsible for the security and compliance of their data in the cloud, right? So we basically provide the cloud, and on top of the cloud that we provide, customers need to be responsible for how they encrypt their data, whether it be in transit, at rest, a combination of both, how they have their firewall set up, how they have their users set up, how they're running their operating systems, what the patch level of the operating system is. Even though we provide AMIs, for example, right? It's still up to the customer to be able to go to the latest and greatest configuration there, and have any relevant kernel patches or security patches as part of that. If they're running, say, something like EC2. Different story if we're talking about something like RDS, right? That's something that's all done as part of the platform behind the scenes. So interesting thing to note there. So this is just going to go through, I'm not going to spend too much time on these slides. We've got a lot to go through, but this is just talking about more of the physical security of our data centers. Like I said, nondescript facilities. You're not going to be able to drive by the highway and drive by a road and say, hey, that's an Amazon data center, that's an AZ. Doesn't really work that way. These are all nondescript. We like to keep them under wraps. So there's a lot of different access controls there. Again, going back to some of the hosts, the hypervisor, we run the hypervisor, whether it be the newer Nitro hypervisor or the older Zen-based hypervisor. That's all within AWS's purview on our side of the shared responsibility model. And these are things that you're going to want to make sure that as a not just for the exam, but in general, who's going to be responsible for these things. So there's a little, I'll take a pause here, and I'm not going to not going to ask you for answers, but I'll take a pause here for about 30 seconds, read through some of these, and just kind of mark down either mentally in your head or mark down on a sheet of paper or on a notepad document that you have open, which of these would be a customer responsibility and which one would be an AWS responsibility. And we'll take 30 seconds starting now, and then we'll come back, and I'll come back and we'll see how we did. Okay, so it's been about 30 seconds or so. In the interest of time, I'm going to continue on, but this is basically the answer key for the previous slide. So which of these were customer responsibilities? Which one were these were AWS responsibilities? I'm not going to go through each of these, but hopefully, if you were playing along, you got most of these right, if not all of them. And if not, just make sure that's a good opportunity to understand that you might need to read a little bit more about our shared responsibility model. And we've got a lot of documentation out there that'll help you understand it a little better. So security, like I said, with AWS is job zero. And in the fullness of time, as we say, we have a number of different services out there. You're not going to have to know all of these for the test, right? You may need to. It may be helpful for you to understand that some of these exist, but they're not going to be asking you really deep, true 400 level questions on things like guard duty or security hub. They may ask you how things work together, right? Especially with things like IAM, KMS, to a certain extent. And this is where the exam guide is really going to help you understand the level of depth they want here. But it's really helpful to understand all the different the foundational security services and functions that we have out there, not just for the test, but in general, because public cloud, in my opinion, public cloud doesn't work if customers don't feel secure about having their data here. So that's why we continue to innovate and continue to release all these services to help customers secure their data, report on the security of their data, monitor their data, take action with some of these items, and we're going to, in the fullness of time, we're going to continue to see this slide like this getting even more busy with a lot more security-based functions, and that's a great thing. So let's see here. Oh, and there's a couple more things. So big key here is identity and access management, IAM, right? So IAM, as you probably all know what IAM is by now, right? It's a way for us to authenticate, authorize, and even audit through CloudTrail with using Amazon Web Services. So this is for IAM is basically nothing more than our password store, right? So you've got like Active Directory, for example, right? That's a password store. LDAP could be considered a password store. And that, to me, that was an easy way for me to think about it when I was starting to learn about it. So if I wanted to create an AWS user, I would go into IAM. If I wanted to grant a user access to something, I would go into IAM. If I wanted to create a role, IAM. So anything authentication based generally is going to be IAM. Then there's going to be some different pieces there, like S3 bucket policies and SCPs with organizations. We'll get to that in another time. But basically, from an authorization perspective, what are users allowed to do, right? So we've got the root or account owner. They are basically, for all intents and purposes, they're God. They can do anything. And the root, and because of that, we recommend that customers basically never use the root account. They only use it when they open up the account and then change the password to something really secure, enable MFA, preferably on something like a hardware token, and then basically lock that MFA token away in a vault and never go back to it again, because everything else should be done by IAM user, because there's traceability, right? Think of it this way. If you've got John Doe and Jane Doe, and then you've got the root account, right? And there's a security breach, right? Someone did something they weren't supposed to do. It's a lot easier to go back to CloudTrail logs and figure out if it was John Doe or Jane Doe that actually did the malicious action compared to if someone logged in as the root user account, They just logged in as a generic account. You don't know who logged in, and they can change things like billing. They can close the account. All these things you really don't want people to give access to. So that's why we recommend root be used very, very infrequently. Secure the heck out of it, and never really use it, only except for emergencies. So, so as a result of that, so now that we know, root can kind of do everything. There's policies that are defined both at a user and a resource level that basically say, okay, what can we do as an IAM user? So by default, if you don't attach a policy to a user, if you don't make them part of an IAM group, they're going to have access to nothing. So if you create an IAM user, forget to put any sort of IAM policy there, they're going to be able to log in and not do much else. It's going to be a very upsetting experience for them, and that's a good thing. It's a secure posture, right? So we don't want to allow them to have access to everything by default. A real key piece with authorization and IAM to consider is, I don't know if you've heard this term used before, is the concept and the principle of least privilege, right? So if John Doe only requires access to EC2 and Jane Doe only requires access to S3, then they should only have access to those specific services. And I would argue, having S3 full access to me would be too much. I would want to lock that down even further to say, okay, which bucket does that user need access to? What specific actions does that user need access to, right? Because there's a big difference between granting a user the ability to list the kind of objects in S3, read the kind of objects in S3, or write to S3. So at MySpace Storage, we see a lot of this where we might grant an IAM user the ability to write objects out to S3, right? Because those are backups, right? But we don't provide them the opportunity to read, right? Until a restore is needed in certain situations. And why would we do that? Well, because if those account keys, if those user credentials get compromised in any way, right? They get published out on GitHub, right? Then the best that they could do is write more data if they can. It's going to be in a proprietary backup format anyway. They can't list it, they can't read it. So those are some of the things that we do, further down the road. So that's where you really want to kind of understand and work backwards from what does this user actually need, and that's going to get you very far once you start thinking about things like that concept of least privilege. So another thing here, how do we know who you say you are, right? So this goes back to this is where MFA is a really big thing, and not just so much with AWS, but anything else, right? If your bank account, for example, right? PayPal account, anything that's sacred to you, and even stuff that's not. In general, MFA is always a really good thing to have. We support hardware tokens. We also support the ability to use apps like virtual tokens, virtual MFA devices like Google Authenticator. And I think now, I haven't used this personally, but I know that there is support now for things like YubiKey as an MFA device. And what this really prevents against is if somebody gets your ID and password, somebody gets your credentials, whether you be a console user or even an API user, right? Now, API is a little tougher, but especially with the management console, you don't want somebody to just be able to log in if they have those credentials, right? So that's why we really recommend MFA. So if your credentials do get lost or stolen, or you get a keylogger for some reason on your keyboard, MFA is of great importance. A little more complicated when we start talking about programmatic users with access keys and secret keys, because programmatic users, an access key and a secret key is nothing more than a username and password, right? So that's where we start looking at things like, can we do role-based authentication? Can we do things like our STS service to grant them temporary access keys, which expire after a while? And if not, then one of the big recommendations with using access keys and secret keys is that they get rotated often. Unfortunately, I see a lot of customers who will create users, and they'll have access and secret keys out there for well over a year. And you don't really know, since it's a username and password, nobody's really logging any. They're logging it, but not everybody's also is minding the shop to see who's logging in with these keys. So if they get into the wrong hands, and if they have access to more than they should, it can be pretty tough day for them. So now let's talk about some IAM principles, right? So what is a principle? Principles are something you could start using with things like bucket policies, but also with IAM policies, right? So a principle would be something like an account owner ID, which would be the root account, could be an IAM user, a group, or role, or it could also be something like a temporary security credential, which can last anywhere from 15 minutes to well over a couple of hours in order to do that. And if we look at the different hierarchy of privileges, like I said before, that root account owner kind of has access to everything, right? Unrestricted access, all services are enabled. Even if you granted an IAM user full administrator access, there are certain things like closing accounts, changing support plans, changing your payment methods. All that can only be done by a root account user, right? So, but by the root user. So, really can't stress enough how important it is to secure that root user. But as we look at this, we look at the pyramid fashion, right? So the root account has the most danger here, right? And has the most privileges, right? But as we start going further down with the IAM user, it has less. You can restrict it by policies, whether it be a group policy, an inline policy, or a preset user policy. Then you have temporary security credentials, right? And they're only going to that's where role-based access control gets in, or STS, right? And that's going to really help you further secure things, because you're only going to have those credentials for a specific amount of time. It's not like an access and a secret key where you could have that out there for a year, and who knows how many different hands or how many sets of eyes were on that that secret and access key, right? So if we take a look here in terms of some of these different groups, right? So one of the best practices we have with IAM is using things like groups, right? So rather than if you have an IAM user, rather than granting them putting inline policies or even specific policy documents, attaching that to the user, it's best to create IAM groups and attach policies to that group. This way, here we've got 3 groups: developers, admins, and test. This way, if all the users in this group need access to the same pieces, it's easier for you to manage that, right? So if you need to change things, instead of changing the IAM permissions for two IAM users with inline policies, you just change the group, and boom. In a situation like the developers, you'll be changing that for 3 users at once. But the key there is that you really want to make sure that all of those users in the group need access to the same things. If not, then it's not really following that concept of least privilege. So now we're going to talk a little bit more about role-based access control and IAM roles, and why they kind of make sense and what they are, right? So if we think of something like an EC2 instance, an EC2 instance, you can launch it without a role, and if you needed access, if you were going to spin it up and you were going to launch it, going to SSH to it on a command line, for example, right? Let's assume it has the AWS CLI configured, right? If you want to access an S3 bucket, right, or another AWS service that requires IAM credentials, there's generally 1 or 2 ways to do it, right? You can either attach that IAM role to the EC2 instance, and that's going to provide AWS credentials from that role to where you don't have to create a specific IAM user, or you can create an IAM user and have that access and secret key pair. Well, we prefer, the best practice is to go with role-based access control, as you probably know, because this role can basically be used by the operating system, can be used by the application running on that EC2 instance to be authorized to utilize other AWS services, such as Lambda, such as access to S3 or CloudWatch, right? And the benefit there is that there's no real credentials to change hands, right? It's gonna use that role-based access control. It's gonna get those temporary credentials. So all that's gonna happen behind the scenes, and it's going to be specific to that EC2 instance. So some people I've seen, they have a role for each EC2 instance. If they need access to different, if each of those EC2 instances need access to different AWS resources, some will just create a single IAM role that applies to a group of EC2 instances, right? Really all depends on the AWS resources that need to be utilized as part of that. So I'm going to talk a little bit about AWS organizations, and this is kind of this is an interesting concept, and one to me when I first started with AWS, it was kind of tough to grasp, but as I've been doing this for longer, it's something that I feel, especially now, the way AWS is going and the way customers are using us, we're realizing that one account isn't enough. It used to be where companies would just some legacy companies, back, AWS has been around for a number of years now, right? It's been around since most of our services have been around. We started S3 in 15 years ago. So a lot of these customers that were using AWS back then, they would generally have one account, right? Single account for their entire company, and they would have dev, they would have test, they would have prod in there. The problem with that is that you're starting to intermix a lot of different things, right? You may have someone that has access to an RDS instance in one account. That's a dev instance, right? And in the same account, there's a production instance, right? And it becomes really tough to manage that. And then, heaven forbid, somebody goes in with too much access and starts deleting things, right? Either by accident or by choice. Can get really disastrous. So over time, we've realized that AWS accounts, we don't charge you per account. You pay for what you use, right? So so AWS accounts are an easy way to kind of delineate specific things like different business units, different environments, so that everything isn't being shared in a single AWS account. Really helps reduce some of that blast radius. So. And that's why we're seeing things here like when you start having many teams, you have different security and compliance controls across accounts. When you start dealing with different business units, you want to start isolating workloads, and you just have different business processes. And then you want to, what's even more difficult then is if you have a single AWS account, with the exception of, say, tagging, it becomes really difficult to understand, okay, who used what, right? Especially if you're in an organization that's doing chargeback, right? If you just get one big AWS bill at the end of the month and all your EC2 usage is mixed across business units and across environments, it's really tough to understand and kind of dive deeper into how that was used. So that's where one isn't enough. So this is where we start going into, that's why AWS organizations is so powerful. So you may have heard this, we have a number of different, names for our account structures, right? The newest term is now the management account, is that top level account. It can also be called a pair account, but that's the administrative root of the organization, right? The older term that we've used, which is no longer used, is a master account, right? A master and linked accounts, but that's basically that top level there in an organization. And all that really does is that just sits there as the administrative root. That's only used, nobody really, generally people don't deploy services in there. That's generally just used as a billing account. And that's something where maybe you would, folks would consolidate things like billing, they'd consolidate other things like this is where they create their accounts from, but they generally wouldn't run any workloads in there. But then they would have these separate linked or member accounts below them. And then they would also create these in different organizational units, right? So we're seeing 3 different organizational units that comprise 4 different AWS accounts. Account 1, account 2, account 3, account 4. And you can create any different number of organizational units within an organization. So you can say, okay, I've got a batch of accounts that needs to be production in our production OU, and test accounts and a test OU, dev accounts and a dev OU. And that's really what's being shown here, is that each of these accounts, these A's are accounts, and the dev, test, and prod are these organizational units, which just make it easier to manage because you'll be able to apply policies and guardrails to different, depending on the organizational unit. Or you may just want to have you may just want to start off with one organizational unit. It's completely up to you. So, and then within those accounts are the resources. So it becomes a lot easier to manage. It can also become more difficult to manage. So with some of these accounts, you want to make sure you have a strategy up front before you just start creating this. And these service control policies, I talked about guardrails before, and we're going to talk a little bit more about what they are in the future in future slides here. But these are really going to help kind of restrict what actions can happen inside these accounts. So these are going to work together with IAM to generally I see customers doing explicit denies in these service control policies where they'll only allow certain actions to happen within that set organizational unit. And we'll talk a little bit more about that in this slide here. So in this example here, these SCPs or these SCPs are going to be allowing any EC2 actions or any S3 actions. But let's say for this example, you've got you're in an organizational unit where you have this SCP applied. And let's say you're logged in as an IAM user who only has access to do EC2 and SQS. Well, the way they work together is it's only going to allow you to what it matches. So even though IAM is allowing you to do SQS, SCP is only going to allow you to do S3 and EC2. So there has to be a match on both sides in order to allow for this. Now, why does this matter? So this is to ensure that only certain people in these organizations, especially when it comes to things like dev and test accounts, or even production accounts, right? They may only want certain services to be utilized in some of these accounts, right? Or certain actions within those services. So that becomes really critical, especially as we look at accounts at scale, right? They only want, if you have dev accounts that are restricted and you only want them to be used for RDS, right? You would only allow RDS actions, right? Or you have dev accounts or production accounts that are specific to S3. That's where that really comes in. So how are customers using organizations today, right? And how are we recommending customers do this? So like I said, we have this organizations management account. It really is just for billing, creating your service control policies, very limited access. This is kind of like that top level piece here. Now we start looking at some of the different core accounts, right? So we look at things like logging, right? So this would be a account that exists just to have logs sent to it. So you'll have S3 buckets, you'll have different restrictions on those S3 buckets, things like MFA delete. This is where you'll send your CloudTrail logs to, any security logs. And this is where you'd maybe have your security operations team would be the only folks that would have access to these accounts. And then, you could also have potentially data center connectivity to this, right? If you've got tools like Splunk or any other sort of SCIM tools that you want to have out there, either have the ability to read this or not. Generally, what would happen there is we'd have a separate security account, right? And that security account could have access to the logging account in order to do things like that, right? So it could have that cross-account access to the logging account to grab those logs. But this is where the security tools would run out of. So if we have things like Security Hub or Guard Duty, right? These are all tools that allow for these to allow for kind of like that member and linked sort of thing, right? So you can log into Security Hub in this security account and see any sort of issues for any of the linked accounts below that, and that would all be done to the security account. Shared services account, this is where we start seeing things like a lot of networking, right? So this is where you would have your data center connectivity would be done to this account. If you got any direct connects, DNS would run out of this account. Anything if you're running AD, if you've got, say, golden AMI pipelines, if you want to build your own EC2 instances, this is where all that would do, because this would be basically shared across all of your different accounts. And this is where so that's kind of like your core. So once you have that core set up, this is where you start looking at things like having these different account structures set up to where you could have this. So in this example, you've got a number of different developer sandbox accounts that might live in a separate OU. They're sending all their logs to the logging account, but security is also having the ability to go look into that, right? There may or may not be connectivity back to the data center. But this is where you start logging. This is where you start want to lock developers down in terms of what they can and can't do based on SCPs and IAM restrictions. And this is where we can start looking at, that's developer accounts, and now we start looking at things like different resource accounts, right? Maybe some customers like to break this up by business units. Some like to do it um, by way of environments, right? So really depends on the customer in terms of how this multi-account strategy looks like. And what this is really intended to just show you is that this picture here is just how your typical customer would use, say, a multi-account structure to start, right? And there's more than one way to do this, but this is generally how we see customers do this. So let's talk a little bit more about encryption now, right? So encryption in security is big, right? Most if not all of our AWS services support some sort of encryption in transit. So you're never, in most circumstances, you're not going to be wanting to run things like telnet server on an EC2 instance, for example, right? Because that's all being sent in clear text. So you want to make sure that everything you do is encrypted in transit, and our services support the ability to do that. But again, this is a customer responsibility in terms of how they have this set up. Although we will generally, like if you were to launch an Amazon machine image, like an Amazon Linux machine image on an EC2 instance, we're not going to have telnet enabled by default there, right? So we're gonna try and have a good security posture, but we're not preventing customers from doing that either, right? So it's really up to the customer to be able to not only set up, but try and enforce things like encryption in transit, and then also set up things like encryption at rest. Things like there's ways to do this at the bucket level in S3, for example, right? With EBS, we support the ability to make sure that your EBS volumes are encrypted with a specific key, and we can do that at the account level with EBS. But again, that's all customer responsibility. And the nice thing about for the most part, encryption at rest and encryption in transit does not result in any sort of penalties from a performance perspective. So, so the performance, unless you've got seriously low latency, like I'm talking about the microsecond latency sort of area, that's where encryption might be something might sort of have an issue there. But in general, generally speaking, in 99% of the use cases, if there is no performance penalty as a result of this, and even that 1%, there's probably going to be a way around that to use something like an instant storage if you need block storage that's encrypted at the hardware level, but doesn't really have any impact. So I talked briefly about some of the different encryption at rest mechanisms, both at the volume, objects, and also the database level as well. Once you start getting into some of the higher level encryption mechanisms with things like transparent encryption on Oracle and whatnot, as well as MySQL, then that's where you start seeing performance penalties. But if you're using things like KMS to encrypt the database at rest, or encrypting objects at rest, or EBS volumes at rest, that generally does not have the performance penalty associated with that. We do provide, when we talk about key management service and our KMS keys, we provide the ability to have a customer master key that allows you to basically create keys. We have default keys for services. The recommendation is not to use them. And even if you don't plan on doing anything exotic with them at the get-go, where I see customers running into issues a lot of times with KMS is that they just use the default keys, the default service keys, like a default EBS service key, and then further down the road, when they want to be able to copy a snapshot from an EBS volume into a different account, it won't work because we don't support the ability to copy snapshots across accounts if they're encrypted with a default service key. So a good best practice here is to create different CMKs, as we call them, customer master keys. You can create that. You can create one for each service, like an EBS or RDS. You can create it for different. You can create it for, if you've got multiple RDS instances in an account, you can create separate KMS keys and only attach them to different business units. it is a best practice to basically scale your your CMKs as much as you can as well. So another thing here that you're probably going to see a lot of on the tests is talk about some of these services that from a configuration management perspective, right? So so things like Amazon Inspector, right? So Amazon Inspector is a service that will run on EC2, and that's a vulnerability assessment service that will report up to the service. So a security someone who's doing in your security team who wants to kind of see what your posture looks like, and what your findings on a specific instance or group of instances, what their vulnerability posture looks like. This is where Amazon Inspector is going to be very helpful. It does integrate with a lot of our tools now, and it's fairly inexpensive. But it is something. There's something like Amazon Inspector. You're going to want to know. You don't really need to know this service in depth, but just understand. What would be helpful is to just understand what services it would run on, and at minimum, what sort of findings and what sort of finding groups it would be able to report on. Like I think there's NIST standards that it reports on. It might be I forget off the top of my head which ones it does, but basically just understand how this works at a very, very high level. Another thing you're probably going to be asked about a lot is CloudTrail, right? So there's CloudTrail, there's CloudWatch. We're going to get to both very shortly. So CloudTrail, every API call that you make in AWS, whether it be at a console or whether it be whether you're doing like a CLI command or an AWS SDK command, is going to be logged, right? And that logging mechanism, we call it CloudTrail. And CloudTrail is very helpful to understand who did what, when did they do it, and where did it happen from, right? So this is our auditing mechanism, and this is where you can go and look and see. This is meant to basically look after the fact. Usually it's about a 15-minute delay from the time the API was actually called to the time this is actually written to a CloudTrail log. So keep that in mind. But this is our auditing mechanism. This is how we audit API calls or IAM user actions in AWS. CloudWatch is different in that it's not so much monitoring security, although it can if you wanted to, with a custom CloudWatch. With custom CloudWatch metrics, you could do something like that, but it's really meant to be more of, say, a performance dashboard. I like to think of it as a performance dashboard, and you can also use it. CloudWatch is also used for things like auto-scaling groups, to where you can set alarms and react to changes. So with auto-scaling groups, it requires a CloudWatch alarm to be created, for example, right? And this is where you can start doing things like dashboards, right? So you can create custom dashboards in CloudWatch and have one for your operations team, have one for your security team, have one for your database team, and they can put whatever metrics they want to there as well. There's also something called CloudWatch Logs. And the nice thing about CloudWatch Logs is it's an agent you can install on your EC2 instances and forward all the system logs and even application logs to a centralized CloudWatch Logs repository. So you can go in there, you can view the logs, you can even, if memory serves, you can even go there and create alarms based on some of those logs. So it's a nice single place to go and store and look at logs, rather than having to go on each EC2 instance, because especially if you're using things like auto-scaling groups, those EC2 instances may be ephemeral and they may not last for very long, depending on how things are going. Another thing to consider here, VPC flow logs. So first off, you have to enable VPC flow logs, right? It's not enabled by default, but you can enable this per ENI, per subnet, per VPC. This goes to CloudWatch Logs. But this is where you can start looking at, this is helpful when you need to look at network connections, right? Inbound, outbound connections, especially if there's connection issues. I know a lot of folks that will turn these on and keep them on. Other folks will enable these only when necessary, just because it can produce a lot of traffic and a lot of logs. You can also alarm on these metrics if needed as well. But because it's network-based, it can be very chatty and just produce large scales of logs. So just keep that in mind. So I'm not going to get into too much here. Another thing I want to spend some time on is, which I would be surprised if you didn't see this, but it's good to know regardless whether you see it or not, is AWS config. So AWS Config, this service's claim to fame is it's a configuration management service. So when you can enable AWS Config and what it's going to do by default is record. It's going to baseline your AWS services, right? So an example of one of the things you can do with AWS Config is you can have it look at your S3 buckets and see if there's any public read or public write enabled there, right? And if so, you can either have it alert you via email, via SNS, or you can actually have it, you can create a Lambda function and have it fire up a Lambda function. Of course, you'd have to create this Lambda function, but it can even, you can have this be an event that kicks off a Lambda function that actually removes any public access that is enabled on an S3 bucket. So it's great for things like inventory. It's great for things like for change management to kind of, because this kind of shows point in time in terms of when something changed and what changed, right? And it allows you to kind of react there. So you have to enable it. There's a cost involved with AWS Config, but this kind of helps you understand what changes were done to the environment. Yes, you can go back to CloudWatch if you want to, but the nice part about AWS Config is that rather than just doing reporting, this is where you can start actually taking action like I was talking about earlier. So this is kind of an interesting, this is an interesting kind of a animation, but this config rule is basically showing how it's going to be used. This is basically going to be a config rule, if I remember correctly. Yes. So you're going to see here like different versions of things, right? And you're going to get to, and what you're seeing here is you're seeing that there's one resource here that doesn't match that is not compliant with a config rule. So if something is not compliant with a config rule, right? Looks like there's an instance and a volume that are not compliant. And that's where you can kind of deliver those results there and then deliver that output to someone to have them take a look and say, okay, was this change expected? Was it not? And if not, what was the change? So if they need to roll back, they can do that. But expect to see AWS config on your test at some point. So you're definitely going to want to learn more about AWS config. So I know we only got a couple of minutes left here. I do want to go through just a few more things and then we're finished up. So Trusted Advisor. So Trusted Advisor is a great tool that can be used to basically show, it's going to scan your environments and give you recommendations that based on our best practices. So we see here that it's scanning, it's showing that there's unrestricted ports in your security groups. Some of your S3 buckets are improper, right? There are different tiers of Trusted Advisor, right? So there are certain things that we will give you for free. And then there are more complex Trusted Advisor checks that can only be enabled if you have business support or enterprise support enabled on the AWS account. But if memory serves, I think it's all security, most if not all of our security checks are free. It's where some of these cost optimization and performance Trusted Advisor pieces are more expensive, but it would be helpful for you to understand, in my opinion, a little bit more about Trusted Advisor, what it can check, what it can't check, and especially what it would provide for free and what you'd need to pay for in terms of some of those metrics. We've got Amazon Macie. This is a service that can be enabled, and this is helpful for customers who have sensitive, either HIPAA or PII, personally identifiable information that would be in their S3 buckets. So this is a machine learning service which will show and provide reports on things that may or may not be issues, right? And shows you when access is denied, when access is granted, and it's going to be very pattern based. So don't see too many customers using this, but it's good to know it's there in case they need the ability to secure and help prevent some data loss in their S3 buckets. We're going to talk a little bit about Guard Duty now. So Guard Duty is a service that runs, and the nice part about Guard Duty is once you enable it, there's no real agents to go on. It's going to be taking in data from sources like your VPC flow logs, CloudTrail events, data plane events in S3, DNS, and it's going to be smart enough to kind of baseline what's usual and what's unusual activity. I'll give you an example. I was working with a customer one time, and they had a guard duty, and they've been running just fine in one account, but they realized that that another account got a guard duty alert because apparently they had an open security group and they were running an unpatched version of Linux, and they got hacked, and somehow somebody decided to be running a Bitcoin mining operation from this EC2 instance. How was this found by guard duty? Well, they were reading through things like VPC flow logs and seeing that there was a difference, that there was an unusual change in the destination traffic. And so it's a really powerful tool. It's fairly inexpensive, and in my opinion, it's something that's a best practice that should be enabled on your accounts, on your AWS accounts, because it provides simple agentless ability to find some of these threats as the threat landscape, especially from a security perspective, just keeps getting crazier. So what can it detect? Like I said, so things like Bitcoin mining operations, if there's an EC2 instance that's running known malware infections, it's going to look for these kind of these threat patterns. And Bitcoin mining obviously is a big one. So, and the nice thing is it's a service, so that it's not like there's anything that it's not like with a virus scanner where you need to constantly update the signatures. This is all being done behind the scenes. They regularly update their guard duty patterns with new features, new functionality, and a lot of that's done behind the scenes. So as threats emerge, there's really nothing for you to do other than just look at your guard duty dashboards and just make sure you're looking at the right things. So we've got a couple of security resources I wanted to share with you here, and in addition to our security blog. But in the final minute here, I want to make sure that I'm clear on some of the exam resources that are available, and I'll be sharing this deck with Tim to share it with you guys later. But we've got quite a lot of different resources here for the exam. Review the guide, review the sample questions regularly. You may or may not see some of these on the actual test, so you want to make sure that you're very comfortable with those. Make sure we review our AWS white papers on things like well-architected framework, VPC connectivity options, how our AWS pricing works. There's a lot of different FAQs that are out there for you to look at, just so you can be comfortable with the services. And then, like I said, make sure hands-on is being part of your study plan. Make sure you're mindful of your cost there, because there have been times when I first started learning AWS, I got stuck with a $300 bill because I was creating a lot of different resources and I forgot to spend them down. So that was a $300 lesson for me early on. And then lastly, if self-study isn't an option for you, there are some really good third-party training options out there, like A Cloud Guru, Udemy, and whatnot, that provide exam training options and course material that's specific to this exam as well as other exams. So that's just another resource for you. So I'll be sharing this with Tim. Any questions? I know we're kind of out of time here, but any questions before we kind of wrap up here? All right, so no questions. I want to thank you all very much for your time today. Like I said, I'll be sharing this meeting will be recorded, so you'll be able to access this later on, and I'll be sharing this slide deck with Tim later to post that internally. So thank you all very much for your time, and it's been a pleasure.
And thank you very much, Anthony. Yes, that slide deck will be available in the graduate training. And just want to emphasize what Anthony said, that the continuing training is a huge part of your AWS journey, your cloud journey, and your information technology journey as you move forward. So the video will be posted in the class also, and that'll happen a little later this afternoon. You can all review it. For those of you who are watching for the first time, thank you for your attention, and thank you all for coming, and thank you, Anthony, once more.
Thank you. Have a good weekend. Bye now.
Yeah, you too.